Be careful. Every once in a while, I'll throw a little softball in there just to get you. Okay? So just check. Does that make sense, you guys?
Wait, what was this question again?
Just like, well, if you get the negative, can't you just go flip? You know what I'm saying? Just go negative, positive, negative. Usually, yes, that's what's going to happen. But you just have to be careful sometimes. Sometimes it's, you know, if you're doing a sign chart on this, this is going to be, this is 1. If this is x minus 1 squared, this is the derivative function equals x minus 1 squared. I do a sign chart at 1 it is equal to 0, but the derivative goes positive to positive, so what does that mean? You know, that's not, I mean, it's not neither a min nor a max. It's always increasing. Okay? Let's do this one, and then this is a good subtle difference. Okay, so I have my sign chart made for this function where the derivative equals 0 and the intervals when it's increasing and decreasing. From this, can I determine if this point is a min or a max? And how can I do that, Michelle?
You can kind of draw out the graph like the shape of things. So
Okay.
if it's negative, it's going downwards, and then it goes upwards.
Yeah.
So if you look at it, that would be okay.
By the first derivative test, since f prime changes from negative to positive at the critical point, that makes it a min. That means the original function changes from decreasing to increasing. If the first derivative changes from negative to positive at the critical point by the first derivative test, you got yourself a min. What can I say about at 2 then?
It's a max.
It's a max. How can I say, Chris, that that's a max?
It goes from positive to
What? What's it? And be careful, you guys, on the test with pronouns. You know what I'm saying? They want you to be very specific. What is it in this case?
the original function goes from the derivative goes from positive to negative.
Do you see that? You know, see the original function. I have no idea what the original function is doing. Since the derivative changes from positive to negative at the critical point, the original function has a maximum there. Okay? Be careful with those pronouns. All right. So good. So again, did everyone fill out your increasing and decreasing intervals? Yes?
Mm-hmm.
Okay, so increasing between 0 and 2, and again, I include my endpoints, and it's decreasing, parentheses, negative infinity, all the way to 0, included, union, bracket, 2 to infinity. That's where it's decreasing. Okay, so we're getting a lot of information so far. Would you agree, Brandon, about the information we've received so far is a lot? Then let's keep on going. Okay, so what did this tell me down here, Brandon? I saw second derivative was equal to 0, and I wrote x equals 1. What is that telling me? A possible inflection point at x equals 1. Because, Amina, just like you need a change in sign in the derivative to get a min or a max point, you need a change in sign in the second derivative to have an inflection point. And I'm going to show an example of that. Okay? So, second derivative equals 0 at 1. So then I check a point to the left. What's a point to the left of 1? 0. I plug in 0 into the second derivative, and do I get positive or negative? Positive. Okay, I check a number to the right of 1. Such a number is, Allie? 2. I plug 2 into my second derivative equation. Do I get something positive or negative? I get negative. Great. So, do I have an inflection point at 1? How do I know that? Yes, I have a change in sign in the second derivative. If you have a change in sign of the second derivative at 1, and the second derivative equals 0 at 1, okay? So I got an inflection point at x equals 1. I got a min at x equals 0. And again, it asks for the value. Again, be careful, I'm just putting the location here, but it asks for the value, so you have to solve for that. A maximum at x equals 2. Look at all these questions we're answering. Do I know concave up and concave down? How can I tell that, Magdalene? How do I know something's concave up? Salad bowl up. How do I know that from the sign chart where I'm salad bowl up?
Because the signs are different.
Well, how can I tell from this information where I'm going to have salad bowl up in the original function? What do I know about salad bowl? What do I know about concave up? Do I know the sign of the second derivative? What is the sign of the second derivative for salad bowl up? 50-50 shot now. Just take it. Take it.
Positive?
Yes! Very good. Second derivative is positive. You have concave up. So what interval is this function going to be concave up then, Mugly? Everything up to what?
1.
Yeah. So concave up, negative infinity all the way to 1. Concave down. Sandy.
From 1 to.
Yeah. Okay, great. Now again, another interesting way to tell that 0 is a min and 2 is a max is using the second derivative test. What the second derivative test says is take your critical point, Estelle. Take that critical point, x equals 0. X equals 0. And jab it into the second derivative. If I put a 0 into here, what do I get? I put a 0 into this, into the second derivative. I get a positive value. So if I know that at f prime of 0 equals 0, and f double prime of 0 is positive, I know that's a max. Min. Sorry. How do I know it's a min? Well, you have a critical point that's concave up. Does that make sense? At the critical point, you have a second derivative positive, meaning it's a critical point, and at that point it's concave up. That makes it a min. Does that make sense, you guys? That's the second derivative test. It's super useful because you don't have to make a sign chart. You don't have to check to the left and to the right. If you can, calculate the sign on the second derivative at the critical point. You just have to check if it's positive or negative at that specific point. If it's concave up, you got yourself a min. Now at this point here, at 2, f prime of 2 equals 0. I plug that in 2. I plug 2 into the second derivative, and what do I get? Yeah, I get a negative value. What does that mean, Eric? What does it mean if I have it at the critical point that I have a negative second derivative?
That means that it's concave down.
It means at the critical point, that function is concave down. What does that tell you about the extreme value? It's a max. Does that make sense?